What's up, guys? Am I audible? Guys, am I audible? Okay, 500 plus. Oh हो ये क्या चल रहा है भाई? Oh, 500 audible. Sorry, 500 man. This is crazy. OMG. This isn't a resignation video, it's a graph video. So I am not expecting so many people to be live. But yeah, welcome to the stream, guys. Welcome to the stream. We're gonna do some serious stuff in the next 7 days. ठीक है, 7 days. कुछ हाँ थोड़ा सा लेट हो गया, नहा रहे थे थोड़ा, सोचे थोड़ा फ्रेश होकर चलते हैं, बहुत लोग आने वाले तो थोड़ा नहा रहे थे. ठीक है. Okay, so we're gonna enjoy. So before starting, let's quickly wrap up. Let's quickly wrap up with the introduction. और ये last page क्यों खुला हुआ है? Let's quickly wrap up with the introduction. Okay, so फटाफट थोड़ा सा promotion वाला scene है, फटाफट कर देते हैं and फिर we will get started. So for everyone who's new out here and who doesn't know me, let me introduce you myself. My name is Raj Vikramaditya. I'm known as Striver in the programming community. I'm a competitive programmer. I am currently working as a software engineer. I'm a candidate master at Codeforces, a 6-star at CodeChef. I have been teaching from the past couple of years, and I also run a YouTube channel where I have 1 lakh plus subscribers. The subscribers that I have gained by teaching and teaching only, no clickbait stuffs. And the subjects that I take are competitive programming, data structure algorithms, C++, interview preparation. And you can definitely use my coupon code Striver in order to get 10% discount on the Unacademy Plus subscription. Now there is something which is known as Relevel. Now what is this Relevel? Now you must be applying to companies, right? But you don't get opportunities, or you don't get a call back. Now, Relevel is a platform where you can directly apply to the company by just giving a hiring test. Now you don't need to have a degree. If you have skills, that is something which Relevel wants. So let me just tell you, it's basically India's first test hiring platform where you go give a test, you get a specific score. Using that score, you can apply to around, I think, 500 or 50 plus, 50 plus startups, including Cred, Razorpay, Coordination, 1MG, Urban Clap, and many more. Now there are 1,000 plus job openings specifically for 3 positions: business development, front-end development, back-end development. So you can just attempt this test and go and apply. Now registering in Relevel is very, very easy. You can just go and sign up, give the test, and then you will get the interview scheduled, and after that you will be hired. So go ahead and check out Relevel, and you can book slots as per your choice. There is nothing special. Okay? And once you get your score, you can create a video resume which will be visible to all the recruiters. So please make sure you register for Relevel. If you haven't joined the Telegram group of this particular community, please make sure you join that out. And right at the end, if you're new to this channel, do consider subscribing. Hit that subscribe button. Hit that subscribe button, and like kar do, stream like kar do. 1,000 likes as a target. So yeah, I'm gonna teach on iPad. I hope that's okay to everyone. Let me know if the iPad का वो पूरा visible है कि नहीं, मतलब visible है ना पूरा iPad का ऊपर का. Relevel is free, guys. Relevel is free. We're breaking records, man. 500 on a live stream for teaching. That's crazy. That's some crazy shit, man. Okay, let's go. Let's get started. So how many of you know no spamming? Let's get started, and let me tell you what will be the content for the 7 days. 7 days. How is this different from the series that is uploaded at my channel and everything else I'm going to tell you? So day 1 will be where I'll be telling you graph and representations. Graph and representation is what I will be telling you. Okay? Next, we will be talking about the traversal techniques. Right after that, I will be telling you like cycle detection techniques. So remember, in traversal, there is one specific traversal which is known as BFS. Now this BFS is asked a lot in Amazon. Yes, like Amazon, Microsoft, Google, they keep on asking this particular algorithm. BFS. So I'm going to solve around 3 problems. Okay, so in traversal, specifically on BFS, I'm going to solve 3 problems. And there is another one, DFS. Over here, I'll be solving a couple of problems. Okay, and those problems will be graphs, but it will be on matrix, so that you can visualize how a matrix can be visualized as graph. Okay, that is what I will be planning for today. That's for day 1. Going forward in day 2, like tomorrow, we can discuss without wasting time. Are you guys ready? इतने सारे लोग कैसे? अरे मैंने LinkedIn पे पोस्ट कर दिया था. I posted on LinkedIn, that is why. I posted on LinkedIn, that is why. I posted on LinkedIn, that is why. हाँ, अभी थोड़ा मैं 700 वॉचिंग देख के पगला गया हूँ. आई हैव गॉन क्रेजी बाय वॉचिंग 700. अरे ये ब्लैक, अच्छा कान फट रहा है क्या? थोड़ा सा कम कर देते हैं. अब ठीक होगा, अब ठीक होगा. ठीक है, रेडी, शुरू. ईयरफोन में कान फट रहा है, ठीक है. ये ब्लैक फ्लैक नहीं हो सकता, यही कलर मिलता है आईपैड में, यही कलर है. कैन नॉट हेल्प इस कलर के साथ. अरे क्या कलर फलर होता है? पढ़ाई करने आए हो या फिर शादी करने आए हो? कलर देख रहे हो, हद हो गया. हदी है. ओके, लेट्स गेट स्टार्टेड. व्हाट्स अ ग्राफ? It's a very important data structure first of all. Now, where is this graph used? Google Maps is one of the primary examples. Google Maps is one of the primary examples. So you would have seen, ठीक है, you would have seen Google Maps, right? Now, how do you, like, you give the source and you give the destination, right? So the Google Map tells you the shortest distance nowadays in terms of time, and also it gives you an option in terms of all the other options. So have you ever wondered how this Google Maps work? So generally Google Map works in terms of, like, it uses internally graphs and all the other data structures to figure out what is the shortest distance, and it shows you that particular shortest distance. There's a lot of algorithms that are being implemented. So specific, like, the use case that is always visible to you of graph is Google Maps, something like that is being used by. पढ़ाई करो ये. Please, just a quick request to everyone, since I'm starting to teach, don't deviate me by commenting weird comments. If someone is commenting, ये आपका ड्यूटी है, आप उसको भगा दो, ठीक है. Don't deviate me, because I'm teaching. I don't want any controversies, any random off topics. Let's focus. 2 hours we are going to focus, and today let's make sure when you go back you will be having a lot of stuffs. Okay, so if anyone is spamming out, please, that's your responsibility to stop him. Okay, there's no need to code. Today will be like when I reach to BFS, then you can code. Okay, so in graphs there are a couple of things. One is the nodes, or generally it's known as the vertex. Okay, nodes or vertex and edges. Okay, so what's a node? So in graph, if I draw something like this, let's draw something like this. Okay, if I draw something like this, you generally call this guy as the node. These are nodes. Okay, like if I just tell you that this is node 1 is a node, 2 is a node, 3 is a node. Okay, these things are nodes, and you can also call them as vertexes. Okay, now what are these things? These are edges. These are known as edges. Okay, now what I'll say is, for this particular graph, yes, for this particular graph, I can say that there are 3 nodes and 3 edges. Now, is there a particular relation? That if there are so many nodes, there has to be so many edges? No, there is absolutely no particular relation. You can have any number of nodes, you can have any number of edges. There is nothing like itna hona padega. Okay, so that's the specialty of graph. You can have any number of edges. Like probably you can have like if I just give you an example, you can have something like, if I take a graph like this, like you can have something like this also, where you see the number of nodes are 4, the number of edges are 6. So it's not necessary that the graph can have, like, it's not necessary that the edges has to be interlinked with the number of nodes. That is something which you have to be like Sure. So that's something. Now, critical thing, has the graph to be connected? Like, we'll come to that on specifics, but as of now, let's understand this is a graph. Now if I just give you a structure where I say 1 2 3 and then I say 4 5, you will also call this as a graph. This will be called as a connected graph. Remember this. This will be called as a connected graph, whereas this will be called as a disconnected graph. Remember this. This is a disconnected, whereas this is a connected graph. Always remember this. It's not necessary that all the nodes of a graph has to be connected. It might not be. They might be in दो different planets में भी हो सकते हैं. It's okay. It's okay. Okay. So coming across now, what kind of graphs are there? Now there can be graphs like directed. So let's understand what is a directed graph. यहाँ तक clear है सबको? यहाँ तक clear है सबको? यहाँ तक clear है सबको? For people who are wanting to enjoy the stream, full screen कर लो, comments नहीं दिखेंगे. Make it a full screen, you'll not see the comments. Okay. Make it a full screen. Clear है अब यहाँ तक? Okay. So no, not two graphs. It's not two graphs. It's a graph with two components. It's a graph with two components. Okay. Now over here, if I just erase this, then I'll say it's a graph with, this is a component, this is a component, and this is a component. So there are two components. Got it? This is a component and this is a component. It's okay. You should not say कि यार दो graph है. No. In a problem, it's always a single graph. You can say multiple components. Don't. It's never like कि तीन graph दिया हुआ है. Yeah, 3 components can be given to you, 4 components can be given to you. But in a question, they will never say कि यार दो graph दिया है, 3 graph दिया है. ना. Components. Okay. Cool. So what's a directed graph? Till now, I did draw graphs which did not have any direction of edges. Like if I call this, there is an edge between 2 to 3. There's an edge between 2 to 3. But can you say me ये edge कौन सा तरफ है? Is it from 2 to 3 or is it from 3 to 2? Like, what do you think? Where is the edge from? Is it from 2 to 3 or from 3 to 2? You're not sure. Are you sure? I don't think you're sure. So this is something which is known as undirected edge. Undirected edge. Remember the term. It's known as undirected edge. Okay. Where you can move from 2 to 3. Like, you can move from 2 to 3 as well as 3 to 2. Like, there is no direction. If there is no direction, you can move from 2 to 3 and from 3 to 2. So it is something which is known as a undirected graph. It is something which is known as undirected graph. Got it? Now, whenever I say directed graph, this can be an example of directed graph. Yeah, it's a tree. It's a tree kind of a data structure, but you can still call it as a directed graph. As I said, it's not necessary that the number of components and the number of nodes or they need to form a cycle. As long as there are nodes and they're connected by edges, you can tell them as a graph. Okay, like in the undirected graph, even this, like this is a tree data structure. This is a tree data structure, but you can also call this as a graph. It's okay if you call this as a graph because these guys are nodes. These guys are nodes, and these guys are edges. These guys are edges. So you have nodes, you have edges. Got that? Clear? A tree can be a graph. A tree can be a graph. Remember this. A tree can be a graph, but a graph cannot be like all graphs are not tree. A tree is a graph, but all graphs are not tree. Remember this. Clear हो गया? कोई doubt है क्या? कोई पूछ रहा है? Can a single graph? Yes, it might contain. Aditya is asking, can a single graph contain both directed edge and yes, it might contain. Every tree is a graph, whereas a graph is not a tree. Okay. Cool. Okay, directed graph. This is a directed graph. Now, someone did ask me a question. Is it necessary? Like, I can also represent it I can also represent a undirected graph via directed graph. How? Let's assume this is an undirected graph. Okay, let's assume this is an undirected graph. How can I represent this as a directed graph? It's very simple. You write 1, you write 2, you write 3, and you say, okay, 1 to 2, 2 to 1. Yeah, you can draw two edges. Now, can I say this is a directed graph? Can I say both are same? Yeah. This is a undirected, whereas this is a directed. Is the concept clear? Is the concept clear? A undirected graph can also be represented in a directed graph. Is this clear? क्लियर हो गया? नोट्स, अरे पढ़ाई करो ना, नोट्स बनाना तुम्हारी मर्जी है, तुमको पढ़ना है कि नहीं. ओके, नाउ रिमेंबर, इट्स अ वेरी a tree, every tree has a property, every tree has a property which, since I'm teaching graphs, I'm not teaching. Every tree has a property. The property is, if there are n nodes, then the number of edges will always be n minus 1. Remember this. Every tree has this property. Every tree has this property. Like if you see, if this is a tree, it has 3 nodes and 2 edges. Every tree has a property. It has n nodes and n minus 1 edges. In graphs, this property is not seen. As I said, there is no relation between nodes and edges. There can be any number of nodes. There can be any number of edges. Okay? Tree is a undirected graph. A tree is an undirected graph until unless someone specifically mentions you ki there is only an edge directed from this to this, then you call it as a directed tree. In most of the cases, we deal with undirected trees like normal tree. In graphs also, in most of the cases, we will be dealing with undirected graph, but in some cases we will be dealing with the directed graph. Clear? Is that clear? Yes, Astotherma, there can be any number of edges between this. Now, it's not necessary you will only have 2 edges. It's not necessary that you will only have 2 edges. I can also draw like this. I can also draw like this. 1, 2, this. There can be any infinite number of edges between two guys. Any infinite number of edges between two guys. Don't focus on code. I'll be telling you in such a way that you can understand in Java and C++. Doesn't matter. My teaching style is something very different where I don't focus on languages. ठीक है? अरे we are not doing tree यार, ये सब क्या question कर रहे हो? If there are 2 nodes and have 2 edges, no, you cannot. Now that is why it cannot be. Remember, a tree means, tree is very different. See, a tree is a data structure which is something like this. Got it? There is only a single edge between 2 nodes. In a tree, there is a single edge between 2 nodes. In graphs, there can be multiple edges. There can be no relation. There can be anything. But in tree, there will only be a single edge between 2 nodes. Remember this. Don't complicate stuffs. Don't complicate stuffs. I always say don't complicate stuffs. Usually what happens with all of you people are, you're like complicating the easier stuffs and then you mess up a lot. Don't complicate. Keep it simple. The simple definition is there are 2 kinds of graph, undirected and directed. The undirected graph means no direction of edges. Directed means direction of edges. As simple as that. No relation between nodes and edges. Got it? आगे समझ? Okay. Let's move across. What is a weighted graph? Let's understand what is a weighted graph. Now when I say what's a weighted graph, let's understand the meaning of weighted graph. Now weighted graph is something, when I say that, hey, this is the graph, okay, and assume these are the nodes weights, okay, these are the graphs and these are the node weights. So what I'm saying is, sorry, edge weights. So what I'm saying is, this edge is having a weight of 1. I'm saying this edge is having a weight of 2. I'm saying that this edge is having a weight of 2. This edge is having a weight of 3. You can correlate this, yes. You can correlate this to a Google map, right? You can correlate this to a Google map. For an example, I say Kolkata is a node. If you go from Kolkata to let's say Mumbai, the distance is probably 1 5 6 7 kilometers. I'm just guessing. From Mumbai to Goa, the distance is probably something like 300 kilometers. From Mumbai to Pune, so these are, you can just correlate, right? You can correlate, right, as a graph. So these are the weighted graph. Assume 200 kilometers. It's a weighted graph with distances. So weighted graph, clear weighted wala concept, clear weighted graph wala concept. Whenever I attach a weight to an edge, I call it as a weighted graph. Whenever I attach a weight to the edge, I call it as a weighted graph. Clear? Got it? Okay. Guys, don't ask silly doubts. That is what I'm asking. I know none of the doubts are silly, but you are asking doubts like ye kya hoga, ye kya hoga. Nah. Focus on whatever I'm teaching, then you can go back home, you can do your research, and if you have still doubts, you can use the Telegram community to discuss. There are people who will answer you. Okay? Okay. Now, this is undirected. Na? In Google Maps, it's undirected. Kyun? अब तुम कोलकाता से you can go to Mumbai as well, and from Mumbai you can come to Kolkata as well. So it's an undirected graph, right? Directed graphs are basically those things जब तुम रास्ते पे देखते हो ना, one way होता है. Those are directed graphs. Like बहुत बार होता है ना, रास्ते में गाड़ी सिर्फ एक साइड जा सकता है, उस साइड से नहीं आ सकता. Those can be called as directed examples of real life, right? Okay, let's move. Okay, let's move now. C++ Java. I will not be focusing on C++ Java. I'll be writing pseudocode. So as of now, can you tell me how many C++ users are there and Java users? How many? As I said, weighted graph can be anything. Whenever you attach a weight to an edge, be it directed, be it undirected, it is called weighted graph. You can call it as weighted directed graph. You can call it as weighted undirected graph. Anything you can call it, okay? C++, Java, okay, anything. So if you're learning graphs, you should not be complaining whether it is C++ or Java. No complaints. Whether you're learning C++ or Java, koi complaint nahi hona chahiye. Okay, pseudocode. So first thing that I have to explain you is representation of graphs. It's very important, because if you're solving a problem, unless and until you store the graph in some data structure, how will you solve the problem? So the first way is to create a 2D matrix. Both in C++ and in Java, I hope you know how to create a 2D matrix. In 2D matrix, it's समझ गया सारा language आता है सबको. Got it. 2D matrix is something which is known as adjacency. Remember this, adjacency matrix. It's a very important term. Remember this in your head forever. Adjacency matrix. Now, generally, how's the input given to you? So let's take an example of the graph. So I'll draw a mini graph over here. Assume I'm drawing an undirected graph as of now. Assume I'm drawing a mini graph like this. Okay, assume I'm drawing a mini graph like this. So generally the input pattern in all the questions, in competitive programming, in lead code, in everywhere, like in coding rounds, the input pattern will always tell you the number of nodes. So over here the number of nodes are 4, right? And the number of edges are 4. So always the first line will contain the number of nodes, which is definitely n, and the number of edges, which we can call it as m. N and m. Next, we'll always follow m lines. What I'm discussing as of now is the input pattern for a graph. Next, we'll always follow m lines. Now, what will these m lines contain? I am seeing that there is an edge between 1:2. I am seeing that there is an edge between 1:2. So what I will do is, I will say there is an edge between 1:2. So that's the first edge that I'm saying. Next, I'm seeing there is an edge between 2:3. Next, I'm saying there is an edge between 1:4. Next, I'm saying there is an edge between 3:4. Now, before you have any doubts, these edges, there are 4 edges, 1, 2, 3, 4. They will always give you 4 edges. They will always give you 4 edges. It's not necessary that the 4 edges will be given in certain order. It can be any order. Probably 3, 4 can appear first, 1, 2 can appear after that. It can be in any order. The input, the edges can be in any order. Okay, that's the first thing. The next thing is there is an edge between 1:2. So if 1, 2 is given, it's okay. They can also give you as 2, 1. That's also okay. As long as they are saying you it's an undirected graph, it absolutely doesn't matter whether the edge is between 1:2 or is from 2:1. Make sense? This is how the input will be given to you. This is how the input will be given to you. Clear hai? Understanding the input is very important. Generally in arrays, they tell you I'll give you n and then I'll give you n integers. Array input is like this, na? Array input is like n, then I'll give you n integers, right? So in graph the input pattern is like this. Is that clear? I've cleared all the doubts. I've cleared all the doubts about order. I have cleared all the doubts, like it can be 1, 2, 2, 1, anything. Clear है? एक बार में मैंने सारा doubts cover कर लिया. Wait, Yash. As of now, I'm explaining you undirected graph. Represent undirected graphs. We are representing undirected graphs. Then I'll teach you representing directed graphs. Then I'll teach you representing weighted directed graphs. Don't worry. ठीक है? अरे वेट, तुम लोग अपना क्यों बोलने लगते हो? वेट करो, जस्ट वेट. Let me teach. Okay. So let's I'll just erase and tell you how's this stored. I know a lot of you have a lot of idea about these things, but you need to understand there is an audience who is watching, so they might not be knowing all the things. So I have to tell all the things, isn't it? Okay. So what happens is you create basically a matrix, and this matrix is of the size of the nodes. Now remember, these nodes can be 1 based or can be 0 based. It's very important. Over here we have taken 1 based. Over here I have taken 1 based, but the graph can also be given as 0 based. But in almost all the problems in Code Forces in lead code, they will never give you a graph like this. This is my assurance to you. They will never give you a graph like this. 3, 4, 10, 12. This kind of graph you will never see. There is a sequence like 1, 2, 3, 4 ही होगा nodes. The node numbering is generally 1, 2, 3, 4. Agar if you see a sequence like 3, 4, 10, 12 and 1, 2, all these things are missing, then the problem setter ने पिया हुआ था. समझ गया ना? Got it? So we have taken 1 based. So if you have taken 1 based indexing, what you'll do is you will create a n plus 1 into n plus 1 matrix. So n plus 1 into n plus 1 matrix. Let's create that. So n plus 1 into n plus 1 matrix is created. Okay. Now what I'm saying is there is an edge between 1:2. There is an edge between 1:2. So what you will do is you'll go to 1 and you'll say, hey 1, on your 2 there is an edge. So you'll mark it. You will mark it. Okay. So this is done. Next, you will say that there is 2 and 3. You'll go to 2 and you'll go to 3 and you'll mark it. So 2 and 3 is also done. Next, you'll go to 1:4. So you'll go to 1 and you'll go to 4 and you'll mark it. Okay, so just a quick one. Let's reiterate. If there is 1 and 2, you will go to 1 and you'll go to 2 and mark it. 1 and 2 you'll mark and the opposite 2 because it's an undirected edge. Undirected. So ulta bhi karna hoga. Ulta is 2 and 1. Perfect. Next, there is 2 and 3. So from 2 to 3, from 2 to 3 and ulta 3 to 2, 3 to 2. So this is also done. 1, 4. 1, 4 means from 1 to 4, 1 to 4 and from 4 to 1, from 4 to 1. Perfect. 3, 4 means from 3 to 4 and from 4 to 3, 3 to 4 and from 4 to 3. So the graph, the adjacency matrix represents the edges if you see over here there is an edge, means 4 and 0 और 0 पे हो गया, मतलब देख लेना ये 0 पे हो गया, 1 पे होना चाहिए था. There should have been at 1. This should have been at 1. This should have been at 1. Sorry guys, this should have been at 1. So yeah, I can easily say that if there is a tick over here, 4 and 1, there is an edge. 4 and 1, there is an edge. Understood the logic? Have you understood the logic? Understood? अरे I'm not an English teacher. Adjacency होगा कुछ spelling क्या, इंग्लिश, मैं इंग्लिश का PhD थोड़ी करके बैठा हूँ. As long as I can give my emotions to you, I'm okay. So is this clear? How do you do this? It's very simple. It's very simple. So if you're writing, I'll write pseudocode. I'll not use Sublime Text because we have C++ and Java users and Python too. So I'll not use Sublime Text. So it's very simple. You will take input of n and m, similarly input of m, and then there will be m edges. So you will just iterate from 1 is to m, and there is input of u and input of v. Basically there are m edges that are given to you. So what you will do is you will create an adjacency matrix of n plus 1, okay, and then you can be like adjacency of uv equal to 1, adjacency of vu equal to 1. Clear hai? Storing clear? Is the storing clear? Okay, as a clear hoga. So what's the time complexity? We're using normal big of m, but the problem that we are having is the space complexity. We are using big O of n cross n for m edges, which is a lot, because there are hardly m edges. There is hardly m edges. If you carefully observe, there are m edges, but the space that you're ending up using is somewhere around big O of n cross m, like near about big O of n cross m. So this is a problem. Remember this. You can only use adjacency matrix if the value of n is very small. N is small, then use. Forget my handwriting, like माफ करो अगर हैंडराइटिंग अच्छा नहीं लगा, बट मेरा हैंडराइटिंग ऐसा ही है. My handwriting is like this only. Okay. Now I'm not talking about loop, I'm talking about space complexity. Guys. This is space complexity. SC is space complexity. Clear है? What's U and V? अरे कुछ नहीं है यार. अब तुम लोग को ये भी नहीं पता था, ग्राफ मत देखो. ये U है, ये V है. Next time ये U है, ये V है. Next time this is U, this is V. Next time this is U, this is V. Got it? Got it? Why n plus 1? Because it's a 1 based indexing, na? It's a 1 based indexing. So if you're wanting to mark 4, the index 4 will only be present. If you declare an n plus 1, na? Because n was maximum of 4. You have to declare one more, na? Clear hai? Got it? Okay, so like, if you're watching graphs, if you don't know space complexity, don't watch graphs. Graphs is for people who are well versed with recursion. I'm again repeating, please, if you're very noob, don't watch it. Graph is a data structure which is learned after you have spent around some time with your data structure algorithms. Like, you know what is a stack, you know what is a queue, you know what is time complexity, you know what is space complexity, you know what is one based indexing. So I will request you, if you do not know what is one based indexing, if you do not know what is stack, what is arrays, what is this 2D matrix, please don't watch, because then you will go and say ki main ganda padhata hu. Trust me, graph is not for people who are like, I hope you understand what I'm meaning to say, right? Please. Prerequisites are, please, recursion. See, if you don't know recursion, please leave the class as of now. I don't want someone to go and say somewhere ki bhai ganda padhata hai. Recursion is the prerequisite. time complexity, space complexity, queue, priority queue. These are the prerequisites. If you have never like ये नहीं कि नाम सुना, हाँ नाम तो सुना है कर लेते हैं, नहीं किया है तो ही क्लास देखो, अदरवाइज मत देखो. आई सी अ लॉट ऑफ इजी क्वेश्चंस which will take me like it है 7 दिन में 70 दिन में नहीं होगा. रिकर्शन, टीसी, एससी, क्यू, प्रायोरिटी क्यू. ठीक है. अरे फर्स्ट कैसे पढ़ा, इतने डाउट्स आ रहे हैं, मैं फास्ट तो पढ़ाना चाहता हूँ. अब लोग पूछ रहे हैं, इफ पीपल आस्क व्हाई n+1 हाउ विल आई टीच मैन. इफ पीपल आस्क व्हाई n+1 हाउ विल आई टीच. आई टोल्ड यू नो व्हाई 1 4 I can draw an edge from 1 to 4 as well as opposite 4 to 1. Someone asked that doubt. मैं फास्ट पढ़ाऊंगा तो फिर वही होगा ना, समझ नहीं रहे. मैं फास्ट पढ़ाऊंगा तो लोग फिर बोलेंगे कि यार गंदा पढ़ाता है. It's very tough to manage an audience of 750 yaar on live. I hope you need to understand this. Okay, so the space complexity that we see is for, let me tell you, this is for extreme noobs. If you're feeling this is going slow, you can watch the graph playlist on my channel. Go and watch the graph playlist on my channel, because whatever I teach today, you will find that on my channel. If you're thinking it's a wastage of time, you can go and watch that. It'll be quick for you. ठीक है, चलो शुरू करते हैं. So the adjacency list is taking a lot of time. The adjacency list is taking a lot of time. So what we will decide is, okay, let's do one thing. The graph was like this, right? The graph was like this. So what I have decided is, today what I have decided is, listen, let's take adjacency list. Spelling, ignore the spelling. What's this adjacency list? It's basically an array. Now I'll tell you what does that mean. Whenever you define int of array of 10, what does this mean? An array of size 10 is created where every index is storing an integer, right? This means an array of size 10 is created where every integer, like every index is storing an integer. So if you declare like this, can I tell you what does this mean? What does this mean? You're declaring an array of size 5. Remember this. You're declaring an array of size 5 where at every index a vector is stored. Where at every index a vector is stored. Okay. Now Java people can use array, list, integer, array equal to new array list. Like over here instead of integer, you can use array list of array list. Okay. Java people can use array list of array list, right? Or you can create an array list ka array. So in C++, it's a vector int of array, list of array, list of array. In Java also you can create array list of array. Okay, array list of array or list of array, whatever you want to create. So what you usually do is, let's understand what do you usually do. Vector int array 10, or in this case array of 5. So what happens is, an array is created. Remember this, an array is created, 0 index, first index, second index, third index, fourth index. A 5 size array is created, and at every index there is an empty vector. There is an empty vector at every index. At every index that there is an empty vector. ठीक है. अभी the moment someone comes up and says, hey listen, there is an edge between 1:2. The moment someone comes up and says, hey listen, there is an edge between 1:2. So what you will do is, you will go and say, hey 1, you had an empty vector na? Why don't you put 2 into your empty vector? You'll be like, okay, I don't have an issue. This signifies that the node 1 has an adjacent node of 2. This signifies that the node 1 had an adjacent node of 2. Okay, so we know that if there is an edge between 1:2, we know that if there is an edge between 1:2, which means there is an edge between 2 to 1. So what you'll do is, you'll also go to 2 and say, hey, you also had an empty vector na? Why don't you take 1? Perfect. So this is how you can store it. Next, if there is an edge between 2 to 3, can we do the same thing? Hey 2, can you store 3? Like, okay. Hey 3, can you store 2? Like, yes, I can. So we stored that. Perfect. Next edge is between 3 to 4. I'll do the same thing. Hey 3, can you store 4? Okay. Hey 4, can you store 3? Perfect. Next, there is an edge between 4 is to 1. Okay. So I will say, hey 4, can you store 1? I'll be like, okay. Hey 1, can you store 4? I'll be like, okay. So can I say ultimately at the end of the day, this is how your adjacency list looks like? Can I say at the end of the day, this is how your adjacency list will look like? Do you agree? Where at the index 1, there is a vector of this. Index 2, there is a vector of this. Index 3, there is a vector of this. Index 4, there is a vector of this. Do you understand this? The graph can be 0 based indexing, can be 1 based indexing. Over here, it's a 1 based indexing. Got it? Right? Clear? Now, how do you take the input? I'll try to address lesser doubts. So, if you take I equal to, similarly, you can take input of u, input of v, similar, and if you run from 1 to m, so input of u, input of v. What's u and v? What's u and v? U is this, v is this. U is this, v is this. U is this, v is this. So you run basically an input of u and v. The next stuff that you'll do is you'll say adjacency of u. Adjacency of u. So basically you're saying, hey 1, hey 1. Adjacency u means the vector. Adjacency u means the vector. Whenever you declare int array of 10 and you write, yes, and you write array of 2, what does that gives? That gives you an integer, right? So if you have declared vector of int of array of 10 and you say something like array of u, what does that mean? It means a vector. So on that vector, you're saying, hey, can you please add v? That's okay. Similarly, you can say, hey, adjacency of v, can you please add u? So in this way, you can create the entire adjacency list. In this way, you can create the entire adjacency list. Does that make sense to everyone? Right? So you can use the pushback. Sublime नहीं यूज करेंगे फिर सी जावा वाले लोग भाग जाएंगे. So similarly in array list, if you're using Java, this dot add, this dot add. If you're using Java, you can use dot add. ठीक है? बड़ा कोड पे we will use sublime text. Don't worry. And smaller code we will not use sublime text. Okay, got it? Okay, perfect. Now what's the space complexity? Now is the space complexity in the adjacent matrix was n into n. What's the space complexity here? Let's assume. So 1, 2, 3, 4, 5, 6, 7, 8. So can I say I took an 8 space? Can I say I took an 8 space? Logically I took an 8 space. That is logical. So on a generic version, you're creating n places. Right? On generic, you're creating n places. N places create kar rahe ho. You're creating an n size. So n for every edge. What are you doing? You're inserting 2 guys. For 1, you're inserting 2. For 2, you're inserting 1. So there are 2 elements inserted. So can I say that the space complexity used will be bgo of n plus 2m. Bgo of n plus 2m in case of undirected graphs. In case of undirected graphs, it will be bgo of n plus 2m. Why n? I repeat, because array of size 5 for that n. Why 2m? Because if there is an edge between 1 is to 2, 1 contains 2, 2 contains 1. That's why what I'm doing is I'm saying n plus 2m. Got this? Is this clear? Why it is n plus 2m? I hope that's clear. Now, a critical junction is over here, a critical portion. You're saying adjacency of u dot pushback of v. Adjacency of u dot pushback of v. Why are you doing v and u? Because it's an undirected graph. So if it's a directed graph, what will you do? If it's a directed graph, what will you do? अगर ये directed graph होगा तो क्या करोगे? बता सकता है कोई मेरे को? If it's a directed graph, what will you do? हाँ मतलब नहीं 2m exactly you cannot call it 2m. Why? Because assume there are other places which are empty. You cannot call it exactly 2m because there might be other places which are empty. It's not necessary every guy has an. If I give you single components, like single nodes, then there will be a problem, right? So to be safer side, you'll call it n plus 2m. Again, it's not exactly because a lot of times you're not using up spaces. But yeah, I hope you understand. Yes. So if you're doing a directed graph, in case of directed graph, this will go off. In case of directed graph, this will go off. This is go off. In case of directed graph, no required. Okay. Now, so you have understood how to store an undirected graph. You have also understood how to store a directed graph. Everyone has understood. Now, what we will do is, we will try to how to store big of n plus m. Yeah, you can call it as near about. Remember, going forward, I will not be writing this. I will always be calling this as big of n because it's near about that. I can call it as big of n. So in competitive programming or any other, you can call it as big of n. Okay, remember this. Okay, how to store weighted graphs. That's very important. So how to store weighted graphs? Very, very important. That's a very important. Can you tell me how will you store? How will you store the weighted graphs? कैसे स्टोर करोगे weighted graph? बता सकता है कोई मेरे को? You'll obviously use adjacency list because adjacency matrix takes a lot of time, right? How to store weighted graph? How to store weighted graphs? So the format will change. देखो एक बंदा ने बोल दिया कुछ समझ नहीं आ रहा है. देखा? मतलब the problem with students is they don't know to write a recursive function and they expect they will learn graphs. This is where the problem lies and फिर वो बोलते कि tough है. Yep, sequence wise follow करो, समझ में आएगा. अगर आप सोचोगे आपको रिकर्शन ही नहीं आता, आपको क्यों नहीं आता, आप ग्राफ सीखोगे तो कैसे होगा? आप ही बताओ कैसे होगा? स्टेप होता है ना हर चीज का. आप सीधा टॉप फ्लोर पे थोड़ी पहुंच जाते हो, आप फर्स्ट फ्लोर चढ़ते हो, आप सेकंड फ्लोर चढ़ते हो. तो किसी को जब आप बोलते हो समझ नहीं आता है, यार मैं इतना स्लो कभी नहीं जिंदगी में पढ़ा है, या लाइफ में मैं स्लो नहीं पढ़ाया हूं. सो यू कैन टेक n, you can take m. Now the m lines will be there. There'll be m lines and those m lines will contain u, v, w, where w is the weight. So what you will do is over here you will like vector of pair vector of pair is what you will declare. Okay, now instead of storing one element, you will say there are multiple elements. For an example, if I take 1:2 and I say the weight is 1, if I write 3 and I say weight is 2, and if I write 4, like if these are the weights, so the adjacency list will be something like this: 0, 1, 2, 3. Okay, and in there are like 1, 2, 1. So for 1, 2, 1, so 1 will say I'm going to store 2 and the weight is 1. 2 will say I'm going to store 1 and the weight is 1. Okay, perfect. Next, 2, 3, 2. So in 2 you will say, hey 3, you have an edge weight of 2. 3, you have an edge weight of 2 and 2. Next, 3, 1, 4. 1, 3, 4. So you will say, hey 1, you have a 3 with a weight 4, right? Hey 3, you have a 1 with a weight 4. So that is how you can do it, right? Got this? How do you store? It's basically a pair. That you will do. Pair in order to store adjacency list. You have to do a pair in order to store an adjacency list. Nothing different. ठीक है, समझ में आ गया? क्लियर है ये वाला चीज? ओके, सो कोड में चेंज क्या होगा? Adjacency of u dot pushback, I'm writing as pb, pair will be vw, and adjacency of v dot pushback uw. That's the only change in code what to store directed graphs, to store weighted graphs. So everyone now knows how to store data structures. Everyone now knows how to store data structures, right? What can I do, Jetha? What can I do? There is a mix of audience. There's a mix of audience. I cannot help ना. देखो, सब अपना ही सोचता है. प्रॉब्लम इधर ही है. जो बंदे को थोड़ा आता है वो बोलेगा भाई क्यों पढ़ा रहे हैं. इस बंदे को कुछ नहीं आता है वो सोचेगा भाई बेसिक बिना पढ़ाए तो प्रॉब्लम कैसे करा रहा है. क्या कर सकता हूँ? I cannot help, right? Okay. No, weighted graph can be anything. Weighted graph can be directed, can be undirected. It can be anything. Yeah, you can take pair class in Java also. You can create a pair class in Java also. There's, I think, pair class in Java too. Okay, cool. So we have learned how to store. Now the traversal techniques that we'll learn. Because without this, as I said, for people who are wanting problem solving, probably let the lecture get uploaded. Fast forward करके देख लेना, और इससे better can you do anything? नहीं ना. For people who are wanting to just watch out problem solving, when the lecture gets uploaded, fast forward and see that. Traversal techniques. There are a couple of traversal techniques. One is DFS, which is depth first search. The another one is BFS, which is breadth first search. ठीक है? Yes. If nothing is said, then it's the graph is an undirected graph. If nothing is said, I teach faster. Because in CP when I teach, in a batch when I teach, they know basics. Over here people are like आ गया बस, उनको बहुत लोगों को basics नहीं आती है. Okay, DFS, depth first search. So we are going to first learn DFS. This is done using recursion. Then you're going to learn BFS. This is done using queue. Okay, so if you don't know recursion, you will not be able to understand DFS. Let's understand DFS. It's very, very simple. It's very, very simple. Okay, let's understand DFS. Let's take a graph. Is this a graph? Is this a graph? Is this two graph or two component? Two component, right? दो graph नहीं, दो component है. So how the adjacency list look like? So we just draw the if I super quickly draw the adjacency list, this will look like 1, 2, 1 से जुड़ा हुआ है 2 and 5, 2 से जुड़ा हुआ है 1 and 3, 3 से जुड़ा हुआ है 2 and 5, 4 is attached with 6, 5 is attached with 1 and 3, 6 is attached with 4. This is how the adjacency list will look like. This is how the adjacency list will look like, right? This is how the adjacency list will look like. I hope everyone understands. Basically, adjacency list, every index stores the nodes which are neighbors of it. Every index stores the node which are neighbors of it. That's how adjacency list does work. Now, how will DFS work? Now, if I say, like, hypothetically, if I start from 1 and then I go to 2, then I go to 3, then I go to 5, it's a depth first traversal. Depth first search traversal. Depth. अंदर अंदर पहले 1, अंदर 2, अंदर 3, अंदर 5. उल्टा भी हो सकता है. 1, अंदर 5, अंदर 3, अंदर 2, अंदर घुस जाएंगे. पहले अंदर जाएंगे ऐसे ऐसे, देखो ऐसे 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 अंदर अंदर पूरा घुस 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 के आएंगे. समझे? पूरा डेप्थ पे जाएंगे. पूरा डेप्थ पे जाएंगे. गॉट इट? सो explaining you in a better way, if this is the graph, so depth first search will be अंदर 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 अंदर. अब 3 जगह है, कहीं भी जा सकते हो. चलो यहां जाते अंदर अंदर, फिर अंदर घुस गए, वापस आओ, अब अंदर जाओ, अब अंदर जाओ. ये होता है डेप्थ फर्स्ट. दिस इज व्हाट यू कॉल डेप्थ फर्स्ट सर्च. अंदर 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 अंदर, मल्टीपल ब्रांचेस है, एक में अंदर, फिर एक में अंदर, फिर एक में अंदर. गॉट इट? अंडरस्टूड? क्लियर है? So the depth first search can be called as first 1, then 2, then 3, then 4, then 5, then 6, then you come back 7, then you go 8. That's the depth first search. Got it? It can be opposite way, like 1, 2, 3, 4, 7, 8, 5, 6. Could have been this way too. Could have been this way too. ठीक है? समझ में आ गया? Deep. Go deep. Cool. So everyone has gone very deep now. So come back from that deepness. ये मतलब YouTube पे पढ़ाने का ही दिक्कत है, लोग सीरियस नहीं पढ़ना चाहते. फिर बोलोगे यार लोग कंटेंट नहीं देता है. Okay, next. So over here, can you just do a single DFS and will it work? No, you definitely need to do multiple DFS, because doing a single DFS will never work. It's practically impossible, because if you start from 1, अंदर जाके तुम 4 पे कैसे पहुंचेगा रे भाई? If you go अंदर, you cannot go back, right? Now there's no convention. There's no convention. So what you will do is, you will say, hey, listen, what I will do is I'll create a visited array. Okay, let's create a visited array. This is something which is known as visited array, and in this you'll be like 1, 2, 3, 4, 5, 6. And you'll mark everyone as 0, which means unvisited. You marked everyone as unvisited. Now what you will do is, you will start off with the main guy. But in order to do that, it's a very important technique which should be followed across every day. So what you will say is, hey, listen, for I equal to 1, I lesser than 1, I plus plus, if visited of I is, अभी तक छुए नहीं है इसको, if I haven't yet touched, I'll go to that and उनसे सारे जुड़े हुए बंदों को मैं छू के आ जाऊंगा. If I haven't touched I, मैं जाऊंगा अंदर, मैं सबको छू के आ जाऊंगा जो कंपोनेंट में है. समझ में? So initially I is 1. So visited of I is 0. Is it? Visited of 1, is it 0? It is. छूने चलते हैं, चलो छूने चलते हैं. 1 पे हूं, DFS of 1 बोलेगा, अरे भाई मेरा बगल वाला बंदा कौन है रे? मुझे दिख रहा है बगल वाला बंदा 2 है. ओ भाई मेरा बगल वाला बंदा 2 है, चल बगल वाले के पास. Let's go to the nearest. So before going, remember this. If the DFS for someone is called, mark it as visited. If the DFS for someone is called, mark it as visited. Okay, so you mark it as visited. ठीक है? After that, अरे मैं ऐसे ही पढ़ाता हूँ. I teach like this only. Don't worry. Don't make a mess. You'd have अरे I teach like this only. Don't make a mess of it unnecessarily. Okay, so DFS 1, right? DFS 1. I mark it as visited. अब 1 पूछेगा मेरे साथीदार कौन है? Who are my neighborhoods? I'll be like, ओ भाई 2 है मेरा neighborhood, 5 भी है, कोई एक में चलते हैं ना, चलो. Whenever you reach 2, now 2 will say, who are my neighborhoods? 1 or 3, कोई भी एक में चलो. I'll go to 1. Sorry, 1 cannot be gone. 1, you cannot go back to 1 because 1 is already visited. ये जब 2 अपना साथीदार, whenever 2 looks for its neighbor, one of the neighbors is 1. You cannot go to that because it's already visited. Visited बोलेगा, अरे भाई वो बंदा किसी और का है, सॉरी वो किसी और का है, तुम क्या ले रहा है इसको, तुम जा किसी और को देख. बोलेगा ठीक है भाई मैं जा नहीं सकता, कोई किसी और का है। 3, so you will go to 3, you will go to 3, and the moment you go to 3 you mark it as visited. अब 3 पे जाके 2, aha, he's taken, so you'll go to 5. When you go to 5, 1 is, so mark it as visited, 1 is taken, 3 is taken, so 5 does not have nodes जहां वो जा सके. First it went 1 2 3 5, you went down down down, अब कोई बचा ही नहीं है, so it'll come back, come back, come back, come back. So the DFS is over. Now do you observe something? Started from 1 2 3 5, 1 से शुरू किया, सबको छू के आ गया, और यहां छुआ जिसको मार्क कर दिया. गॉट इट? जिसको छुआ मार्क कर दिया. गॉट इट? नाउ रिमेंबर, नाउ व्हेन यू कम बैक, ये जो 3 था, ये 5 पे तो चला गया, अभी वापस आया 2 है, 2 3 पे भी चला गया, वापस आया 1. दिस वन विच वेंट टू 2, will it go to 5? Will it go to 5? The call for 5 will not happen. The call for 5 will not happen. क्यों? क्योंकि पहले अंदर जाके छू के आ चुका है, तो फिर क्यों जाएंगे? Got it? Is this clear? Congratulations, Sam. Okay, got it. I'll take some more examples, don't worry, I'll take some more examples. Now, coming across, what I will do is, I will increase this value to 2. 2 is already visited. I'll increase this value to 3. 3 is already visited. I'll increase this value to 4. I see 4 is unvisited. 4 is unvisited. So I will go to DFS and I'll say, hey DFS, go to 4. Hey DFS, go to 4. So I'll go to 4. 4 will say, my nearest guy is 6. So let's go. But before that, I go to 6, right? I go to 6. 6. Does 6 have a this is already visited. Don't go. Come back. Next goes to 5. Already visited. Next gets to 6. Already visited. So can I say I did a perfect DFS traversal in both the components using this for loop? I'll take one more example. Don't worry. Can I say I did a perfect DFS traversal by doing this? Can I say this? ट्री में बोलूंगा, वो ट्री में बोलूंगा. In tree there is no back, like there is no cycle. That's why in tree there is no cycle. तुम अंदर घुस रहे हो तो वापस नहीं आओगे. ये ट्री में नहीं होता है, ग्राफ में आ सकते हो. इसीलिए ये नोट्स वाली जनता मत बनो यार, नोट्स वाली जनता मत बनो. ये नोट्स वाली जनता का कुछ नहीं होता है. नोट्स वाली जनता मत बनो, खुद से लिखो. ओके, लेट्स टेक वन मोर एग्जांपल. Okay, so this is a graph. Yeah, this is a graph, and let's assume this is connected to this. This is a very big graph. So let's tell me if I start DFS, the initial DFS call will start from 1. Okay, 1 will have its adjacent node, like if I just write 1 will have the adjacent node as 2 and 8. कोई भी एक में चले जाओ. So make sure whenever you go, you mark it as visited. So yeah, like I'll mark it visited here only. इधर ही mark कर देते हैं visited. One's adjacent. Who is one's adjacent? किधर जाओगे? DFS किसको बुलाएगा? Where will DFS go? Yes. Where will DFS go? 2 and 8. Yeah, 2 and 8. Perfect. So I can probably go to 2. The moment I go to 2, I'll mark it as visited. मैं बोलूंगा भाई अब तू आ गया, visited. Next, from 2 where can it go? From 2 it can go to 1 and it can go to 3. From 2 it can either go here or either it can go here, but can it go back to 1? नहीं भाई, ये बंदा already कोई इसको छू के आ चुका है, so we will not go there. Instead of that I'll go to 3 and अब इसको छू देंगे. Up from 3 where can you go? 3 can go to 2, but that's already visited. 3 can go to 4, yes, can go to 8. So you can either go here or you can either go here. Let's go. From 4 where can you go? From 4 either to 3, but that's already visited, either to 5, okay, or either to 7. So either 5 or either 7. Let's assume we go the other way, 7. Let's assume, just assumption. From 7 where can you go? Either to 4, either to 6, either to 4 or either to 6. Correct? चलो 6 पे चलते हैं. Right? From 6 where can you go? Either to 5 or either to 7. Can you go to 7? अरे अभी तो छू के आया, कहां से कैसे जाएगा? तो you will go to 5. 5 पे गया, 5 बोला अब भाई ओए और नहीं है रे जाने का, नो वन, कैनॉट गो. 5 बोलेगा अब तो तू, अब मैं अंदर और नहीं जा सकता, गो बैक. अब बोलूंगा ठीक है भाई चलो वापस. This sixth guy said I can only go to 5 और मैं जाके आ चुका हूं, तो वापस चल. This 7 said I've already gone, वापस चल. This 4 said I've already gone to both these guys, so go back. Now comes the main point you have to understand. ये 3 जब 7 4 के तरफ गया था ना, एक बंदा अभी भी बचा हुआ था ना, बचा हुआ कौन था? 8. अब वो अपनी अधूरी कहानी पूरी करेगा, समझ रहे हो? ये 3 इस डायरेक्शन में जाके अपनी कहानी पूरी करके आ चुका है, अभी अधूरी कहानी जो बची थी वो करेंगे पूरी. चलो करते हैं हमारी अधूरी कहानी, है कि नहीं? So now we will try to go to 8. Did you understand? Sorry, not here. Did you understand ये अधूरी कहानी? Did you understand this leftover story? Because 3 went on this, गया, अब वापस आया, अभी अधूरी कहानी करेगा जाके, ठीक है? Okay, so we will go to 8. Now 8 says, where can I go? 8 can go to 3, that's visited. 8 can go to 1, that's visited. So 8 will say either 10 or 9 pe chalo. So I'll just go to DFS of 10. 10 will go to 9, and then it will backtrack, and it's over. Did you see the DFS happening? Did you see the DFS happening? Did you see the DFS happening? कुछ नहीं कर सकते, बहुत स्लो है. तो जिनको फास्ट देखना, आई सेड ना, देयर इज ऑलरेडी अ प्लेलिस्ट ऑन माय चैनल, गो एंड वॉच दैट. देयर वाज दैट ऑन 2x आल्सो. ओके, अंडरस्टूड? इज एवरीवन? एक अधूरी कहानी में गया वापस आया, और एक में गया वापस आया, और होता तो और में भी चला जाता, क्या फर्क पड़ता है? 100 है तो 100 अधूरी कहानी में जाएगा वो, और सारी कहानियां पूरी करके आएगा, ठीक है? अरे एक और आता तो फिर आके जाता. मना किसने किया है? मना थोड़ी कर रहा हूं मैं. जितनी कहानियां सब में जाओ, सबसे आओ. क्लियर? गॉट इट? Okay, clear to everyone, right? Perfect. So let's write the code. The code's very simple. ठीक है? So I'll try to write the code. Okay, I'll try to write the code. Yeah, looks fine now. So let's write the code. Generally in competitive programming, all competitive programmers are habituated like this. I am also very habituated, so I'll also do. हमारी अधूरी कहानी. चलो बढ़िया, तुम लोग अच्छे क्रिएटर्स की तो तारीफ कर रहे हो, या तुम लोग अच्छे बंदों की तो तारीफ कर रहे हो. थैंक गॉड बब्बर ओपी नहीं बोला तुम लोगों ने. लॉल. Yeah, it's good that you guys are nowadays appreciating good creators. That is something which I always was supporting. Always appreciate. See, it's very important that you appreciate the correct person who is working hard, right? अदरवाइज एक दिन ऐसा होगा तो तुम्हें हर दिन सिर्फ अनबॉक्सिंग के वीडियोस ही दिखेंगे. सो प्लीज मेक श्योर यू ऑलवेज अप्रिशिएट द करेक्ट पर्सन. ठीक है. जावा, अरे क्या है, जावा में नहीं लिख सकते क्या खुद से? don't act like for Java code, refer my channel, you'll get all the Java codes. Okay. So how is it? Visit of I is equal to 0, then you say dfs of I, right? That is what you do, right? That is what you will do. So I can say void dfs. I'll say void dfs int node. What can I say? Visit of node, and I can say visit of node. So after this, what? Now, how do you traverse? Traverse for all adjacent nodes and go in depth for each. ये है ना, ये तो कर रहे थे, है कि नहीं? एक आया, एक एडजेसेंट को पढ़ो अंदर, वापस आ गए, फिर एक से अंदर, फिर आया वापस एक अंदर, है कि नहीं? राइट. सो व्हाट कैन आई डू फॉर ऑटो ऑफ एडजेसेंट? लाइक this is the way you can iterate. Like if you just, because adjacence of u, do you remember adjacence of u is a vector? If you run an auto for each loop, so it will automatically run on the adjacent nodes. So if the adjacent node is unvisited, then you will call, अरे भाई जा अंदर से घूम के आ, चल जा तू अंदर से घूम के आ. Is this clear? Is the code clear? Every node you get, you know, till the DFS is not completed, the next adjacent's DFS will not be called. Got it? Got it? Yeah, I'll explain. Don't worry, I'll explain. Okay, got it? अरे रखना पड़ेगा यार मॉडरेटर. लेट्स एक्सप्लेन. या I'll explain. अरे ये कौन है स्पैम कर रहा है? प्लीज कंप्लीट डीएसएस चीट शीट लेके क्या होगा? अरे मैं समझा देता हूँ, देखो मैं समझा देता हूँ. डोंट वरी. कोड है ना दिमाग में, ये कोड है ना दिमाग में, इसलिए बोलते हैं वो कोड उधर लिखते तो इजी होता है समझाने में. ये कोड है ना दिमाग में, राइट? ये कोड दिमाग में रख लो, ये कोड चिपका लो दिमाग में. ठीक है, देखो सी हो भैया. If you need the adjacent nodes of 1, how will you get the adjacent nodes of 1? Tell me that. No, tell me that first. Isn't it adjacent of u? Isn't it adjacent of 1? Isn't it adjacent of 1? What will adjacent of 1 store? 2 and 8. Do you agree? The adjacent will store ना 1 का 2,8 ही तो store करेगा, है कि नहीं? 1 का 2,8 ही तो store करेगा, right? Right? It'll store all the nodes, right? If you look at over here, oh sorry, my bad. Adjacent of node होगा, my bad. So adjacent of node means it stores 2 and 8, correct? अभी 3 वाला केस लेते, याद है 3 वाला केस? ये 3 वाला को क्या हुआ? अगर 3 वाले में क्या होगा? 2 होगा, 4 होगा, 8 होगा. तो फर्स्ट 2 पे आएगा, बोलेगा ये विजिटेड है, मत जा. 4 पे आएगा, ये 4 पे जाएगा, 4 पे डीएफएस करेगा, ये डीएफएस गया, वापस आया. जब वापस आया फिर नेक्स्ट 8 पे गया ना. वही तो कर रहा हूं. अब आया समझ में? Now did you understand? Now did you understand? That is what I'm doing. See, out of IT I'm saying what are the adjacent nodes? कौन है बगल बगल में? दादा नहीं विजिटेड है, चलो घुस के आते हैं, चलो चलो घुस के आते हैं, फिर चलो अंदर चलो अंदर चलो, वापस आ गए, वापस आए, वापस चले आते हैं, नेक्स्ट आईटी कौन है, अच्छा फिर नहीं विजिटेड है, चलो घुस के आते हैं, हो गया, वापस आते हैं, अब नेक्स्ट पे जाते हैं. Got this guys? This is a for each loop, man. This will iterate on the whatever you're storing, whatever on vector of int you're storing on the index, it will iterate on that portion. Got it? Again, I cannot help. If I go fast, I will have 50 users. Okay. So for people who want fast, I have already made a series. Now go and watch it. It's fast. It's very fast. Now clear? Is it clear now? Yeah, if it is 3 nodes, assume if it is like this. तो पहले कहां जाएगा? पहले 2 पे जाएगा, घूम के आएगा, एंड अगर घूमने में 7 को विजिट कर दिया तो और 7 में नहीं जाएगा ना. देखो 2 पे गया, वो घूम के आया, घूम के आ गया. अगर बोला घूमते टाइम में 7 को भी छू के आ चुका और नहीं जाएंगे 7 पे, और 9 को नहीं छुआ तो 9 को चले आओ फिर से. तो इसीलिए तो ये चेक कर रहे हैं. गॉट इट? Okay, so can you tell me what is the complexity? Can you tell me what is the complexity of this? Can you tell me what is the complexity of this? Can you tell me what is the complexity of this? Let's analyze. We're using a for loop. We're using a for loop over here, right? That's a big of n already. That's a big of n that's running. Amazing. That's a big of n that's running for loop. Next, for DFS, if I'm doing a DFS, big of n, all nodes, सारे नोड को एक एक बार तो छुएगा ना. Every node will be touched at least once ना. Every node will be touched at least once, right? So by the way guys, for everyone who's saying vector of vector in, ये correct है. This is an array adjacency list. It's an array of vectors. It's an array of vectors. It's correct. It's correct. For everyone who's saying vector of vector int, it's a different way of defining. You can try that out too. Okay, so big of n for touching everyone. Inside that, you're running a loop for every adjacent nodes. For every adjacent nodes, how many adjacent nodes in total do you have? How many adjacent nodes in total do you have? Isn't it big of isn't it? It is not n into 2m, because overall वो for loop कितना बार चलेगा? Overall, how many times will that for loop run? That is equivalent to the number of adjacent nodes. And what is the number of adjacent nodes? Isn't it 2m? So I can just generalize this to a big O of n complexity. Clear है? Is it clear? Like, I'll take the generalized version. This can be like, might not be, and if it's a single component, this is not required. If it's a single component, you don't need to write a for loop, right? You don't need to write an external for loop. It's a single component. Got it? Is this clear? Explain TC again, please. Yeah, sure. So basically, big of n for the for loop that we are running. This for loop, big of n for this. Now you're actually visiting every node. You're visiting every node. So another big of n. So that's a 2n, n plus n. Now you're running. You're going across every node. You're going across every adjacent node. So in total, the number of adjacent nodes are 2m, because for every edge there are 2 nodes, right? So adjacent nodes are 2m. So in total, you'll go across that. These many edges will be there. That's why. So overall, I can say big of 2n. Okay. हो गया क्लियर? 2m बिकॉज ओवरऑल कितने नोड्स है, एडजेसेंट नोड्स कितना बार वो फॉर लूप चलेगा? कभी किसी का 2 एडजेसेंट नोड होगा, कभी किसी का 3 होगा, कभी किसी का 4 होगा। ओवरऑल कितने नोड्स हैं? 2m ना। गॉट इट? गॉट दैट 2m? Anil, it's 10 o'clock in the night. It's 10 o'clock in the night. Is it clear? Yeah, yeah. For single component, you can call it as big O of n plus 2m. So don't complicate. Just keep it as n. Just keep it as n. That's okay. You can tell the interview it's a big O of n. It's they will not tell you anything. हरक्यूलिस ये वाला बंदा इसलिए क्योंकि हर नोड पे एक बार डीएफएस कर रहे हैं ना, हर नोड पे एक डीएफएस मार रहे हैं ना, तो हर एक बार एक रिकर्शन कॉल हो रहा है। तो रिकर्शन के लिए एन टाइम्स एन रिकर्शन कॉल हो रहा है क्योंकि हर नोड पे एक एक बार जा रहा है। और 2m वो फॉर लूप वाला आया, और ये एन ये ऊपर वाला फॉर लूप। ठीक है, विदाउट फॉर लूप हाउ विल यू डू? अगर एक बंदे के अगर तीन तीन ब्रांचेस है, एक बंदे के अगर तीन ब्रांचेस है, फॉर लूप नहीं चलाओगे तो तीनों में जाओगे कैसे? तो 100 भी तो हो सकते हैं ना एडजेसेंट नोड्स, कैसे होगा? आज शायद होगा, टाइम तो है। प्रॉब्ली टाइम नहीं है, कल ही होगा। कल ही बीएफएस के तगड़ा तगड़ा सवाल करेंगे। आज तो मुझे नहीं लगता होगा। नॉट बीडो ऑफ एन, इट्स बिगो ऑफ एन। इट्स नॉट बीडो ऑफ एन, इट्स अ बिगो ऑफ एन। इट्स नॉट बीडो ऑफ एन, इट्स बिगो ऑफ एन। इट्स वेरी टफ यार टीचिंग 500 पीपल। लाइव 500 को कोई नहीं पढ़ाता यूट्यूब एटलीस्ट डेटा स्ट्रक्चर एल्गोरिथम्स इज वेरी टफ। पीपल टीच बट have you seen live 500 people? Like at least we had 800 when we started. Have you ever seen 800 live? अब मतलब बकवास कोई ऐसा कर रहा है तो वो नहीं, मतलब कोई पढ़ाते टाइम 800 लाइव देखा है क्या कभी? Have you ever seen 800 live in a live class? Yeah, for a week 10 p.m. Okay, I'll give you 5 minutes break. A lot of people are asking 5 minutes break. Yeah, you can ask your questions अगर silly कुछ है. Okay, it's not tough teaching 800 बंदे, ठीक है कोई नहीं, सही सुन लेंगे। 800 बंदे पढ़ाना टफ नहीं है, याद रखियो। 900, okay. Max live, I think it went 800 something. Okay, cool, cool. भैया सर आप सिविल सर्विस कहाँ? मैं थोड़ा सा सिविल सर्विसेज का प्रिपरेशन कर रहा हूँ। नहीं कर रहा हूँ, मजाक कर रहा हूँ। हाँ, मेरे बस पे नहीं है, पढ़ाई बहुत हो गया। क्या बात करो, पुराने क्लासेस में भी 150 तो हो जाते थे। लीड कोड करता हूँ तो 180 हो जाता है, 180 200। कोड, हाँ कोड खोल दिया। अनअकैडमी को बोलो आप रेस दो, पॉइंट पॉइंट प्रमोशन मांगना पड़ेगा लोगों से। Okay, let's get started. So we learned about DFS. Okay, it's a wonderful technique, but where is it generally used? Where it is generally used? We will come to that. We'll come to that. But before that, yes, before that, let's learn one more technique, which is known as BFS. Okay. It's very important. Most of the coding problems are solved using this technique. Like, sorry, most of the Amazon or all these questions are solved using the technique that's known as breadth first search. Let's understand what is this breadth first search. Okay, let's understand something very important. नफरत किसी से नहीं है यार. There is nothing like any hate. Let's not create controversies. बाद में बताऊंगा कभी. Okay, what's a BFS? Breadth first search. Breadth. याद रखो, breadth. First breadth 1. Next breadth. Next breadth. Next breadth. Next breadth. ठीक है. तुम फिर रिपोर्ट करो यार, रिपोर्ट करो ये बकवास जो लोग कर रहे हैं. There is no hate, dude. There is no hate. But just remember one thing. The guy who can write in a Telegram group this stuff, he wrote in the Telegram group this thing. Okay, so I don't have respect for him after actually seeing this. You wanna keep a point? ट्रैवल लिखने से कुछ प्रॉब्लम नहीं होता है यार. लोगों को होता है कि ऑडियंस को पता चल जाएगी स्ट्राइवर कह रहे हैं, तो दैट गाय लिख देते हैं. जिनको पता है वो समझ जाएंगे, अगर जिनको नहीं पता उनको नहीं पता चलेगा स्ट्राइवर के बारे में. दैट्स ओके, यू कैन कॉल मी दैट गाय, आई एम ओके विद इट. बट आफ्टर दैट गाय, oh, so BFS, breadth. So if I give you one more graph, so can you tell me the BFS for this? Can you just quickly tell me what will be the BFS for this graph? क्या होगा इसका BFS? Can you just quickly tell me the BFS for this? तो दो ग्राफ का अलग होता, दो कंपोनेंट का अलग होता. If there are two graphs, then the breadth first search will be different for the first component and the second component. Okay, Utkarsh, thank you, wonderful question. Tell me the BFS for this, everyone. Start with one and tell me what will be the BFS. Start with one and tell me what will be the BFS. 1 2 4. No. हाँ, यही तो पंगा हो गया. No. BFS, you start from here, you travel in the equal depth नहीं, एक साथ फिर एक साथ फिर एक साथ. Got it? You can check this out. कितने लोगों ने सही किया? Yes लिख सकते हो. कितने लोगों ने सही किया? Oh. Got it? Okay, cool. Perfect. 132 क्यों नहीं? अरे हो सकता है, देखो, this can be 132 also. As long as you are visiting, this can be 132, this can be 54 also. It's okay. As I said, it's okay. तुम इसको या इसको लेकिन एक साथ करना है. It cannot be 1 2 4 3. Got it? It can be the opposite too, like 1 3 2 भी हो सकता है, 5 4 भी हो सकता है. ऑपोजिट ऑपोजिट भी हो सकता है. गॉट दिस? ओके, क्लियर है? वन मोर एग्जांपल. चलो देखो, अभी अगर दो ग्राफ है, लेट्स अज्यूम इफ देयर आर टू ग्राफ्स and a graph like this, then you can have any graph. Yes, you can have any graph, either the component 1 or the component 2 first, no matter. 1, then it will be just 2, then it might be 5, might be 3. You can write anyways, that's your choice. 3 5 is also okay. Then 4 and 6 together, or 6 or 4, and then 7. That's how you do it. Next 8, next 9 and 10 together, or 10 and 9. It can be any option. Got this? It can be any option. क्लियर है? अब क्लियर है? या इट कैन बी 1 to 5, लाइक 1 to 5 6 नहीं होगा. समझना पड़ेगा. समझ में आ गया? हैव यू अंडरस्टूड दिस? क्लियर हुआ इस एग्जांपल से? बीएफएस इज द एग्जांपल क्लियर? बेसिकली एक डायरेक्शन में मूव करना है. एक से शुरू करो, एक डायरेक्शन, राइट? नेक्स्ट 2 डायरेक्शन, नेक्स्ट दिस डायरेक्शन, एंड इस पे भी है सेम है. देखो 1 2, next this, so this and this, next this. मतलब एक एक स्टेप, one step that you are taking, one step that you are taking. BFS, got it? Yeah, Unacademy has stopped the CP subscription. They will probably start with something else. Cool. So how do you do this? It's very simple. Let's take a very simple common example. Let's take a very common example. So if you take this, what you will do is very simple. You will take a queue data structure. Remember this. You will take a queue data structure. A very simple queue data structure is what you will take. And what you will do is, if this is the node, again use the visited concept. Let's create a visited concept. So let's create a visited concept. Okay. So if this is 1, yes, if this is 1, what you will do is, you will mark this as visited and you'll put it into the queue. Alright. Next, who is the adjacent node? So this is what you will start. A queue data structure with the root. A queue data structure with the root of the tree. Sorry, root of the graph. Just a minute. One message kar raha hai. A queue data structure with the node, initial node, and you'll make sure you mark that as visited. You'll make sure that you will mark that as visited. Next, let's move across and take this out. Take this out. This is your node now. Of this node, who are the adjacents? Of this node, who are the adjacent? Only 2. So what you'll do is, insert that into the queue and mark it as visited. Perfect. So for 1, all the adjacent nodes are done. Next, Get the next element out of the queue. 2. Next, get the next element out of the queue. That's 2. Who are the adjacents of 2? 3. Take it and put it into the queue and mark it as visited. Take it and put it into the queue and mark it as visited. Done. What is the next? You're done with 2. Take out 3. Who are the adjacents of 3? For 3, the adjacent is 2, 4, 5. But 3 is already visited. For 3, 2 is already visited and 4 is left, 5 is left. So take 4, take 5 and put it into the queue. Take 4, take 5, put it into the queue. In the next thing, take the next element out, which is 4. Again do the same thing. For 4, who are the adjacent nodes? For 4, who are the adjacent nodes? For 4, we see that the adjacent node is 3, which is already visited, and 6. So you'll just take 6 and put it into the data structure. Perfect. Done. Next you'll get 5. Now you have a 5, right? You have a 5. So what you see is 5 is there. For 5, who are the adjacent nodes? 6. For 5, 6 is the adjacent nodes and 3 is one of the others. What you'll do is you will just simply take, something as 6. That's already put, I guess. That's already put. Visit hai. तो और कुछ नहीं करना है. अब let's get the next one. That's 6. 6 is done. Who is the adjacent of 6? 5 visited, 4 visited, take 7. Put it and let's take 7. So if you look at the BFS, first 1, then 2, then 3, then 4, then 5, then 6, then 7. Did you understand how to do this? You can start from anyone. See, it's not necessary you need to start from 1. It's a convention. That you generally start from 1. It's not a stamped rule. That you have to start from 1. That's the difference. It's not a convention, it's just a start rule. Got it? Got it? Shall I code this? You can start from anyone. It's not a stamped rule, it's just a convention that you start from 1. Generally we start from 1 if there is no mention. ठीक है? कोड करें? Shall we code the BFS? So we can again write the for loop for component wala stuff. Remember the component. So I'm not writing the inputs. The inputs will be same. The inputs will be same. Just in case of DFS, it will be a BFS. BFS of node. Okay, so you'll write visited of node equal to 1. You can probably create a queue and you can say queue dot push of node. And next what you can do is while dot queue empty, and you can say int the node will be queue dot front. You just get the front element, and you can say queue dot pop, and then you can just traverse for the adjacent nodes of these guys. And if it's not visited of it, you can say queue like visit of it is 1, and you can say queue dot push of it, and then you like over here you can just over here you can just do this. Is that clear? Is that clear? Is it clear? ऋषभ इज आस्किंग कहाँ मिलेंगे? सर्च करो, इस चैनल पे भी रिकर्शन काफी है. इस चैनल पे आई हैव टेकन अ रिकर्शन क्लास, यू कैन चेक दैट आउट. There's a lot of other instructors taking, you can check it out. Done? Everyone has understood the code? Clear? Yes, yes. If there are two, see, that's why I've written you over here, right? If there are two components, it's gonna be doing a BFS. If there are two components, there is going to be a BFS, right? Let's understand what is happening. You're calling BFS, right? So initially you go and say, okay, इधर से शुरू करते हैं, so let's mark it as visited. इधर से शुरू करते हैं, so let's mark it as visited. Next, you're saying, hey queue, you started from here, so let's take this into the queue. I'm like, okay. Next, take that node out. Yes, I'm taking that node out, and that's a part of my BFS. And अभी क्या करते हैं? इसके जो एक नोड है, इसका बगल के सारे को एक एक उठाते हैं, क्यू में डालते हैं. उठा क्यू. So that is what I've done. Whatever are the adjacent nodes, I just take it off. Yes, I just take it off and I mark it as visited and I push it into the queue. Got it? For every node, adjacent. Take it, put. Got this? So the next time when it comes up, it will again get that guy and his adjacent you'll take and put. Got it? Is that clear? Is it clear? Yes, लिख दो फटाफट. Yes, लिख दो. Everyone can you just write a yes? Quick yes. Can you just write a quick yes? Okay, complexity wise. What's the complexity? Can you analyze me the time complexity? क्या होगा complexity? अभी तो टाइम, अरे प्रॉब्लम करा है, अब आता नहीं है बीएफएस, क्या प्रॉब्लम करोगे? पहले बीएफएस सीखो. What will be the time complexity? What will be the theta? Acha. So the time complexity is specifically big O of n plus again a big O of n plus big O of 2m. It's a similar time complexity. The reason is same. It's a similar time complexity. This for components, this for traversal, and this for the adjacent nodes. Similar time complexity, right? Right. Similar time complexity. Perfect. So we've learned couple of techniques. One is the BFS and one is the DFS, right? We've learned that perfectly. Now what will we learn? Yes, what will we learn? Learn the next thing that's very important. Let's solve a problem using BFS. Let's solve a problem using BFS, and let's see if you can give me some answer. Okay. Generally Rudra, it's written V plus E because वो लोग क्या करते हैं, इसको आप लोग वो डायरेक्टेड के केसेस में लिखते हैं. यूजुअली 2 होता है. It's n plus 2m which is equivalent to that, and they do not consider the component wala loop because they always consider a graph as a one component. So I'm taking the extreme worst case where the graph might have multiple components. Okay. Got it? Clear है? क्लियर हो गया? Test case similar to that guy. Test case similar to the yeah. Okay, let's solve a problem. Both of them are same. Both of them are same. Both of them are same. There's no need to do anything different there. Both of them are same. DFS, BFS, you can use any one. Okay. So remember one thing. Big of n for loop. Big of n for every node, and big of 2n for the inside for loop that you're running. Okay. For topics, you can watch my playlist. You'll get all the topics. Okay. Jiska time waster, you can watch my playlist. There is all the topics there. Okay. Using a BFS, let's understand the question. I will give a start point. Okay, I'll give you a start point and I'll give you end point. So basically, I'm giving you a start point as well as an end point. Okay, so the end is 30 that I'm giving to you. The end is 30 that I'm giving to you. Now I'm giving you some like 2, 5, 10. I'm giving you 2, 5, 10 an array. Now you'll be like, graph padhate hue ye kahan se aa gaya? Over here, there is a logic of graph that you will see. You'll see how graph is implemented in this problem. Okay. So 2, 5, 10. Now I'm saying I have a start. I'm saying I have an end. And I have an array of 2, 5, 10. So what I am saying is, listen, I want you to tell me what's the minimum number of operations. Minimum number of operations required. I want you to tell me what's the minimum number of operations required. Now, what do you mean by a minimum number of operations? What do you mean by minimum number of operations? I say if you do 3 into 2 into 5, from start you will reach end. From start you will reach end. If you do 3 into 10, you will reach 30, which is again the end. So over here you required 2 multiplications. Over here you required 1 multiplication. Okay, what if I change this end? Yes, I just change this end, and I probably say this is 12. I probably say this is 12. In that case, it will be 3 into 2 into 2. So there will be again something like this. So you can use a number as many times as you want. An array is given. You can use a number as many times as you want. Okay, and you just need to multiply. If you can reach from start to end, you will print the minimum number of operations. If it's practically not possible, you will print -1. If it's practically not possible, you will print -1. Is that clear? Is it clear? Clear hai? What's minimum? The minimum number of multiplications you need to do. Minimum operations is the minimum number of multiplications you have to do. Utkash, minimum number of multiplications that you need to do. Yeah, that is okay, but how will you find the minimum number of operations? In short, you have a start, you have an end. You can multiply array indexes, any array element. You can keep multiplying array, any index, ij, any index. And then you need to reach end. The number of times you multiply, those are operations. And you need to minimize these operations. You need to minimize these operations. You need to minimize these operations, nothing else. You need to minimize these operations. सोच के बताओ कैसे करोगे. ओ भाई साहब, ये क्या हो रहा है? मतलब तुमने तो टेलीग्राम ग्रुप पे तहलका मचा दिया है। गुडनेस ग्रेशियस, थैंक यू सो मच, इट्स अमेजिंग। कैसे करोगे? How will you do? Okay, first I'll multiply the largest number. Obviously greedy will not work. Obviously greedy will not work because अभी मैं तुमको ना बीएफएस का नजरिया दिखाऊंगा, तुम बोलोगे ओ भाई साहब अमेजिंग, लाइक अमेजिंग। लेट्स सी। हाँ, चलो देखते हैं। लेट्स अज्यूम द एरे इज 2 5 10। लेट्स अज्यूम द एरे इज 2 5 10, ठीक है। एंड वी आर लाइक we are having the starting point as somewhere around let's say 2, and the ending point, let me just think, रुको। 200, no, okay, 100, let's have the ending point as 100, ठीक है। So let's visualize this as graph, let's visualize this as graph। I will say, let's consider this as the root of the, let's consider this as the root, okay, let's consider this as the root of the graph, let's consider this as the root of the graph। Let's consider this as the root of the graph, ठीक है। Now what I'll say is, what options can you do with this? It will like, I can multiply 2, I can multiply 5, I can multiply 10। I'll be like, तू तो सही है रे, तू सही बोल रहा है रे। Can you say ये पहला ऑर्डर है बीएफएस का, and this is the second level of BFS, okay? Next, let's do the next thing, let's do the next thing again। 4 पे you will be like, hey into 2, hey into 5, hey into 10। I'll be like, ठीक है करो ना भाई, मना कौन क्या, करो। 8 20 40, let's do the same thing again। 2 20 5 50 10 100। oh we reached 100, we reached 100, पहुंच गए। कितना स्टेप? 1 2, the steps answer। अंडरस्टूड? थोड़ा अभी चैट पता नहीं डिले क्यों हो रहा है। आया समझ? I'll tell you, I'll tell you why not recursion, I'll tell you why not recursion, don't worry। I'll tell you why not recursion, I'll tell you why not recursion। I mean, if you understood this, get me a thumbs up first, then I'll tell you why not recursion। I'll tell you why not recursion, but पहले समझ लो इस चीज को। Why BFS, why not recursion and why BFS, I'll tell you why not recursion and why BFS, I'll tell you। recursion कैसे जाता, recursion कैसे जाता? डेप्थ, डेप्थ हो सकता है ना इस जर्नी पे उसको मिलता ही नहीं नंबर, हो ही सकता है ना। if he would have gone into depth he would not have got it, he would not have got it। BFS में क्या है, बराबर चलते हैं ना सारे डायरेक्शंस पे। पहले जीरो डायरेक्शन, एक डायरेक्शन, एक साथ सफर करते हैं। पहले एक स्टेप सारे डायरेक्शन में लेते हैं, फिर 2 स्टेप सारे डायरेक्शन में लेते हैं, फिर 3 स्टेप मिल गया तो रुक जाएंगे। डीएफएस क्या बोलता, एक जा, फिर दूसरा जा, फिर तीसरा जा, चौथा जा, पांचवा जा, छठा जा, एंड सारे का जो मिनिमल होगा वो आंसर है। इन बीएफएस वी डोंट हैव टू गो इनटू डेप्थ ऑलवेज। एक स्टेप मिला क्या, नहीं, मतलब दूसरा स्टेप करना पड़ेगा, दूसरा मिल गया रे, और मत कर। अगर डीएफएस करते होता ये पूरा कहां जाके करना ही पड़ जाता। समझे वाई नॉट डीएफएस एंड वाई बीएफएस? Understood why not DFS and why BFS? Got this? Well, let's solve this using BFS is सबसे easiest way. Like you can use DP, that's okay, but that will still be a lot of time. You can use recursion plus minimize, but since we are learning something as BFS, I wanted to tell you how will this be implicated. We are learning something as BFS, that's why I want to tell you. Okay, now tell me one thing. Can I use a visited guy? And ये visited end तक रख देंगे. मतलब अगर end 100 है तो 1 2 3 4 dot 100 तक. Why? That's again very important. Why? Let's understand why is important here. Like, why do we need a visited? In order to prevent multiples. Why? यहाँ पे 20 है, यहाँ भी 20 है. There are two 20s. Will it make sense to, like, for example, here is also 20. So when you multiply 2, like, assume 100 was not the answer. Assume 40. When you multiply 5, it's 100. And when you multiply 10, it's a 200. So you have already got 40. You would have already got 100. You would have already got 200. So will it make sense to again do the same kind of multiplications? Because if you do one more time, the number of steps will be ज़्यादा. So that's why we use a visited. एक बार 20 का क्रियाक्रम हो चुका है ना, और नहीं करना. एक ही बार. Got it? You just need to do it once. Because if once 20 has been multiplied with all the guys, you will get 40, 100, 200. फिर तो करके फायदा नहीं है ना, फिर भी तो 40 मिलेगा, बट ज्यादा स्टेप्स में. तो मैं क्यों जाऊंगा उस पाथ में वापस? ऑलरेडी इस पाथ में कंप्यूट कर चुका हूं, और वापस क्यों 20 पे करूंगा? इट्स इंपॉर्टेंट दैट यू यूज अ विजिटेड. इफ दैट पाथ हैज ऑलरेडी बीन ट्रैवर्स्ड, there is absolutely no need to do again. Got it? Have you got this? Have you got this point? Why am I saying maintain something like a 20 का visited? क्योंकि देखो, इधर तुम 40 पे पहुंच चुके हो. कितना स्टेप लेके? 2 स्टेप लेके 40 पे पहुंचे हो. तो यहां से अगर तुम फिर से 40 जाना चाहते हो, ये 1 लेगा, 2 लेगा, 3 लेगा. 3 स्टेप, राइट? 3 स्टेप लेगा 40 के पहुंचने के लिए. क्या जरूरत है 40 का 3 स्टेप लेके पहुंचने का? जरूरत है क्या? 2 स्टेप पे तो पहुंच रहे हो. तो ये वाला पाथ क्यों लेना चाहते हो? इसीलिए एक बार अगर 20 का हो चुका है, फिर जिंदगी में आए तो नहीं करना है, क्योंकि वो ज्यादा ही ले रहा है. Yeah, you can call it as something like memoization technique. Like, not memoization, it's an hashing. So can you tell me, when will you stop multiplying? Can you tell me when will you stop multiplying? Raj, I am Pankaj, JGCIT 2023. सीनियर हूं भाई, थोड़ा तो इज्जत दे दे. हैशिंग ही तो किया ना. देखो, ये 20 हुआ तो मैं क्या बोलूंगा कि भाई सुन, 20 तू विजिटेड है, तो ये 20 पे जब मल्टीप्लाई होगा ना, मैं बोलूंगा नहीं, ये ऑलरेडी हो चुका है. समझ रहे हो? ये ऑलरेडी हो चुका है, तो नहीं करना है. ओके, लेट्स सॉल्व इट. ठीक है? So yeah, the moment you cross end, you don't need to write it. So let's solve it. Assume you have the start, assume you have the end, assume you have the array. Assume you have the start, assume you have the end, assume you have the array. So what's the first thing that you will do? You will definitely create a visited guy of the size of n plus 1. That's very important. And you'll say visited of start is equal to 1. And what you can do is you can just probably keep a queue. This time keep a pair of queue. Why a pair of queue? You need to count the steps as well, right? So initially you can definitely keep a start comma 1. You can definitely keep start comma 1, where you say start is the starting point and the number of steps taken is 1. Correct. So we have just sorry, the number of steps taken is 0. Now we can iterate in the queue and we can be like queue dot empty, and you can be like int node is queue dot front dot first, int steps is equal to queue dot front dot second, and you can after that do a queue dot pop. Okay. Next, you can just go on to auto of I links. Sorry, not auto of id, to all the nodes in the array which you need to multiply, and you can say destination will be the node value into array of I. If the destination is lesser than equal to and is not visited, very important, and is not visited, right? And is not visited. What you will do is you will say, okay, it is not visited, so I'll take the destination and the steps will increase by 1 and the steps will increase by 1. Okay, and you can keep on doing this every time. Please make sure you mark it as visited also. And any moment, yes, at any moment you reach a node which is equal to end, you can say these are the steps which are required. And if you keep on multiplying and you ran out of multiplications, you can return -1 and you can return -1. Okay, समझ में आया? सब थक गए, सब थक गए. It's not memoization. It's kind of a hashing that you're doing. Clear hai? Yeah, code. Initially you start with start, so you mark it with 1 and you say yahan se shuru kiya, the number of steps taken is 0. So we start with start, the number of steps taken is 0, so we just put it. Next, if the queue is non-empty, then we start. The node and steps is what we take. The node and steps is what we take, and we have taken the node and steps. So over here we have multiply, multiply, multiply. This is what is being done here. Multiply, multiply, multiply. And if the destination is before end, just and see if that's not previously visited. Put it into the queue and mark it. And any moment you get the end, you return steps. And you can return -1. Right? It's not a lead code problem. Clear ho gaya? It's a good problem. It did come up in one of the coding rounds. That is why I do remember. इतना देर तक प्रॉब्लम चला रहा था, अब करना शुरू किया तो थक गया. Anyways, can you just quickly tell me what will be the time complexity before just wrapping it up? Can you just quickly tell me what will be the time complexity before wrapping this up? What will be the time complexity? If you okay, be it stories, be it whatever you are doing, if you are sharing this, please make sure you tag me. Okay, okay, cool. What will be the time complexity? Very simple. Can I say you will visit all the nodes? At the worst case, you will visit all the nodes from the start till the end. Can I say the complexity will be end minus start plus 1? Like in generic way, इतने ही तो नोड्स होंगे उस ग्राफ में. कितने नोड्स होंगे? एट मैक्स एंड माइनस स्टार्ट प्लस 1. सारे को विजिट करेगा. यस और नो? Yes or no? It's already through while inserting, I'm already marking it as visited. Will the complexity be this end minus start plus 1? End minus start plus 1? Yes, because at worst case the number of nodes it will visit will be सारे elements उनके बीच. Correct? I'll change the tab. Forgot. नो ध्रुव, while inserting if you do it it's okay, while inserting ही कर लो ना, तो इंसर्शन के टाइम विजिट मार्क हो चुका है. Okay, so basically end minus start because at maximum तुम इसको विजिट करोगे, इसको करोगे, इसको all the ones in that range you'll visit, and once you run out of them you're done, right? That's why. Clear? Code again. अरे क्या कर रहा है उत्कर्ष यार, उत्कर्ष जबरदस्ती स्पैम कर रहा है, हर चीज में explain again बोल रहा है यार. This is very bad. If it's genuine tell me, like genuinely नहीं समझ में आता बार बार बोलो, समझ में आता हर चीज पे. टाइम कॉम्प्लेक्सिटी अगेन, कोड अगेन, फॉर लूप अगेन, डोंट डू दैट यार. It's 12 o'clock in the night, man. I understand, like वीडियो अपलोड हो जाएगा तो वापस देख लेना ना, वीडियो अपलोड हो जाएगा तो वापस देख लेना अगर ज्यादा दिक्कत हो रहा है तो. रात को 12 बज गए यार. Yeah, at max we'll visit n minus start plus 1. Yeah, Dhruv, that's correct. That's correct, Dhruv. That's correct, absolutely correct. I don't think my English is that good, but हाँ चल जाता है. इसमें ड्राई रन तो यही है, देखो ये पहले 2 क्यूब जाएगा विथ 0, ठीक है, फिर 2 निकलेगा, मल्टीप्लाई 2 होगा, ये 4 जाएगा विथ 1, ठीक है, फिर ये 10 जाएगा विथ 1, फिर ये 20 जाएगा विथ 1, फिर ये 4 1 निकलेगा, फिर मल्टीप्लाई 2 होगा, 8 जाएगा विथ 2. गॉट इट? अगर समझ ऋषभ, किसी ने तो बोला let them gossip. क्या मिलेगा यार, पढ़ाई करो. Let people gossip. They have achieved everything in their life, right? Cool. Cool guys, thank you for joining in today. I'll share this code. Like इसमें क्या कोड, क्या खुद से करो यार, कोड फॉर शेयर नहीं, खुद से करो. थैंक यू फॉर ज्वाइनिंग इन. कोड अगर समझ में नहीं आया तो कल एक बार बता दूंगा बिफोर द स्टार्ट ऑफ द क्लास. यू कैन डू अ ड्राई रन, you'll understand. बेसिकली इन शॉर्ट ही बता देता हूँ, फिर कल टाइम वेस्ट होगा. देखो 2 था, मैंने बोला Q 2,0 रख, ठीक है, उसके बाद मैंने 2 को लिया तो 2 मिला, इंटू 2 किया 4,1, इंटू 5 किया 10,1, इंटू 10 किया 20,1, राइट. नेक्स्ट व्हाट डिड आई डू? I did a multiply 2, I did a multiply 5, I did a multiply 10. So 8,2, 20. This 20 will no more be taken. Why? Because this 20 was taken, correct? And this way you can just go on. Okay, thank you guys for joining in. It was wonderful. It was wonderful. Like absolutely, I was absolutely glad that you guys joined. Just make sure you do this. If you're sharing it anywhere, tag me. Be it LinkedIn, be it anywhere. Instagram, anywhere. If you're sharing it, please tag me. Thank you guys. You can follow me everywhere at this user handle, which is Trevor_79. I go by the name Raj Vikramaditya at LinkedIn. You can definitely follow me there. Cool guys. Bye bye. Take care. Good night. The time complexity will be into n होगा, सारे notes into n, वो अंदर वाला into n. सही है, मतलब ऋषभ इज करेक्ट. into n नहीं होगा, बेसिकली ये वाला होगा. सारे नोट्स ये n हर बार चल रहा है, ये इंटू n हर बार चल रहा है, तो इसका इंटू मैं भूल गया था बोलना, इसका भी इंटू कर लेना. बेसिकली नंबर ऑफ विजिट्स इंटू n, नंबर ऑफ एंड माइनस स्टार्ट प्लस 1 इंटू n. या कूल गाइस.